So in the three-dimensional geometry yesterday, we have seen the line equation, and also we have seen 3D line in different forms, the parametric form, and how to convert the parametric form to 3D to the symmetric form and the Cartesian form and all this. Let us continue this. Now, if you see the last problem, we have seen this last problem, the direction, let me share the screen, one moment. The direction ratios of the line which is perpendicular to the lines. So for this one, we have seen, we have taken the cross product of the DRs of the both the lines. There is 2 minus 3, 1, 1, 2 minus 2. We have taken the determinant of this, and that is determinant means it is nothing but the cross product, and we have got the DRs of the line which is perpendicular to it. Next is reduction of Cartesian form of the equation of a line to the vector form and vice versa. How to convert the given line which is given in the Cartesian form to the vector form. It is very simple that whenever you take the Cartesian form will always be, we have seen it yesterday, it is in the form of R bar is equal to A bar plus lambda B bar. This one. A bar plus lambda B bar. So this is, if you take x1, y1, z1, it is a point through which the line passes through. If A, B, C are taken, this is these are the DRs of the line which is parallel to the required line. Parallel to the required line. So if you know that, it is done. Now, similarly, whenever the form of the line is given like this: x1 plus a lambda, y1 plus b lambda, z1 plus c lambda, then it can be obviously converted to the symmetric form x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c is equal to lambda. So now the Cartesian form equations of a line are given like this, then vector equation of the line, we have seen this yesterday. In the previous class also, we have worked out this problem. This is converted to x minus 1 by 3 by 1, y plus 1 by 3 by 2 is equal to z minus 1 by 3. Now here, what is that? You have to observe the point through which the line passes is 1 by 3 minus 1 by 3. If you observe the numerator, 1 by 3 minus 1 by 3, 1, and the DRs are 1, 2, 3. And thereby you can write the equation of the line in the vector form as R bar is equal to A bar, means 1 by 3 I bar minus 1 by 3 J bar plus K bar plus lambda into the DRs. DRs are I plus 2J plus 3K. That's it. This is how we convert the Cartesian form to vector form. Cartesian form to vector form. This we have discussed in the previous class also, the same problem, but maybe the question is different. Okay. So similarly, intersection of two lines. How do we decide the intersection of two lines? Means two lines in three-dimensional geometry. I'll tell you the difference. See, if you take two-dimensional geometry. In the two-dimensional geometry, what happens, if you take any two lines, in two-dimensional geometry, if you take any two lines may be intersecting each other, two lines may be parallel to each other, two lines may be coincident with each other. These are the three cases you will come across in two-dimensional geometry. If it is three-dimensional geometry, what happens, two lines may be intersecting each other, it will be there. And two lines may be parallel to each other, it continues from 2D. And similarly, two lines maybe coincident with each other can also be taken. And one more extra property, what you get is nothing but the skew lines. What does it mean by skew line? A line is like this, another line is like this. These are neither parallel nor intersecting. Important concept, please. These are neither parallel nor intersecting. These are said to be skew lines. This is a special case you will have for 3D lines. So because of this only, the planets revolving around the sun or the satellites revolving in the space, they never intersect with each other. The reason is this only. The reason is this only. If you take any two orbits, and you might have heard the words like this: the moon has come very nearer to Earth. The Mars has come very nearer to Earth. So such type of news you might have heard. Then what happens exactly? What is the meaning of the moon has come very nearer to Earth and Mars has come very nearer to Earth and all this? How do we understand this? This is, for example, this is the yellow one is the moon's orbit, and the blue one is Earth's orbit, for example. Then the nearest points are lying here. Just you can see that. But how do we understand at this nearest point? It seems to be intersecting with each other. I'll do one thing. Just a moment. I'll do one thing. I will overlap this so that we will have the better understanding about this. What I do, I'll be drawing this in this way, for example. These are not intersecting. These are not intersecting, not the perfect diagram, but I'll show you. This is like this, let me say. Okay, let me change the color. Like this it is. So the Earth, let me say, is revolving in the yellow orbit, and the moon is revolving in the blue orbit. Then in that case, what happens at some instant? What happens? At some instant, what happens? The Earth will come here and moon will come here. Let me say, whatever. Earth is here and moon is here. There will be a distance between them. And at this juncture, these are not intersecting, please. These are not intersecting. These are, this is a three-dimensional figure. So this orbit and this orbit are different. They never intersect with each other. At this point, what happens? There will be nearest distance for these two planets. For these two planets, there will be nearest distance. That nearest distance is measured by skew lines. That means at that point, if you draw tangent to one line and tangent to one orbit and tangent to another orbit, then what happens? They never intersect with each other, but they will have the shortest distance. So you can count the shortest distance with the use of skew lines. So skew lines, what you have to understand about, they are, the skew lines are the lines that neither parallel to each other, nor intersecting with each other. So what happens in two-dimensional geometry? If they are not parallel, definitely they must intersect or they must coincide. In two-dimensional geometry, what happens? If they are not parallel to each other, definitely they must intersect with each other or they must coincide with each other. In three-dimensional geometry, there is an extra case. If they are not parallel, non-intersecting, then there is another case which is said to be skew lines. In skew lines are the lines where they never intersect with each other. They are neither parallel nor intersecting. Okay, so they will have some shortest distance also. So why I am telling you all this at this juncture? So intersection of two lines we have to talk about. Intersection of two lines happens from the algebraic form. If there is a common point, obviously it is understood. If there is a common point for both the lines, this is first line, let me say, and this is second line, let me say. If these two have a common point of intersection, then we say that they are intersecting with each other. Then how do we decide it? We create. Kaushik and Pranit, do you hear me?
Yes, sir. Sir, there's a bit disturbance in my room because I'm sitting in my house.
Yes,
So
sir,
I'll just
I'm
mute it.
able to hear you.
So if you take the first line, we will create a general point on this. If you take the second line, we'll create a general point on it. What does it mean by general point? These are the general points, arbitrary points, which represents every point and any point on the line. For the first line, lambda taken. For the second line, mu taken. If they are intersecting, now we'll equate these two. By equating these two, you'll get two equations, three equations in lambda and mu. Like this. This is one equation, this is second equation, this is third equation. To get the values of lambda and mu, we require only two equations. So we solve those two equations. Then what for the third equation is? In the third equation, if you substitute the values, it must satisfy. It must satisfy. That's what you have to understand. Okay. So the step 3. That's what the step 3 is. You can see solve any two equations, and if lambda and mu obtained in step 2, if the values of lambda and mu satisfy the third equation, then the lines 1 and 2 intersect. Otherwise, they do not intersect. Okay. To obtain the coordinates of the point of intersection, substitute the value of lambda and mu in the coordinates of general point obtained in the step 1, because it is given that I have just read it. Now we will be doing the problem. By doing the problem only, we'll have the thorough idea about this, and it is also easy. You need not have to worry about that. Let us write the lines. If the lines intersect, what are the lines given? Let me write x minus 1 by 2 is equal to y plus 1 by 3 is equal to z minus 1 by 4. And x minus 3 by 1 is equal to y minus k by 2 is equal to z by 1 are intersecting. Now just say this. Just say this. You will have now clear picture about this. These are the two lines intersecting each other. It is given. Now let me say this as some lambda. This as some mu. Now do you tell me the general point now on the first line, Kaushik? First line is I have taken to be lambda. I need the general point on the first line.
Sir, just a minute.
Now, Pranit, do you tell me the general point on the second line?
Yes,
Sir,
Cross multiply mu plus 3.
mu my
2 mu plus k.
k.
Next.
Mu plus 1.
No, plus 1 is not there. Just cross multiply 1 into mu. That's it. Correct? Now, how many equations we get here? 2 lambda plus 1 is equal to mu plus 3.
Yes, sir.
Second one, please. 3 lambda minus 1 is equal to 2 mu plus k. 4 lambda plus 1 is equal to mu. Okay. So now let us take those equations where k is not present. Solving. Come on, let's solve the first and third equations. 2 lambda minus mu minus 3 is equal to 0. Minus 2 equal to 0 because plus 1 is already there. Minus 2 equal to 0. And the third equation, 4 lambda minus mu plus 1 equal to 0. Okay. Now what happens? Your lambda value, mu value, you will get it like this. Lambda is equal to, and apply the short form of doing it. Short form is minus 2 plus 4. 2, fill the denominator. If you want the value of lambda, close lambda and cross multiply, minus 1, minus 2, minus 3. And if you want the numerator of mu, close mu and cross multiply, not from left side, but from right side, minus 8, minus 2, minus 10. So this is lambda and mu must satisfy the second equation. Lambda and mu
That is the second equation.
must satisfy because they are intersecting.
Yes, sir.
We need not have to prove it because he has given that they are intersecting with each
Just
other.
for our comfort.
So substitute here 3 into minus 3 by 2 in this one. Minus 1 is equal to 2 into mu, please, minus 5 is minus 10 by 2, minus 5 plus k. Please do you simplify and tell me the value of k, Pranit. I need the value of k now. Minus 9 by 2 minus 1.
Minus 5. No, minus 1.
Minus 10 by 2 minus 1. This is minus 10. Bring it to other side. Plus 9.
Plus 9.
Then the value of k must be 9 by 2. The value of k must be 9 by 2. So what is that you learn here with regards to intersection of two lines? Two lines intersect only when there is a common point. Then how do you know that there is a common point? Because in this problem, it is given that they are intersecting. That is why I wrote a general point on the first line and general point on the second line. If they are intersecting, they must be equal. So I equated them, and by equating them, you got 3 equations in lambda and mu. And here, because he has declared that they are intersecting, there is a unknown quantity k here. So what we did, we solved first and third, and by solving first and third, what we have got lambda value, mu value is minus 3 by 2, minus 5. And if they are intersecting, what must happen is lambda and mu must satisfy the equation which is containing k. So I substituted these values in this one, and thereby I have got k value as 9 by 2. Do you understand this, Pranit?
Yes, sir. Understood, sir.
Yeah, well, you take a screenshot and post in the group, please, because he is not present, I think. Kaushik is there? Yes, he's there. Okay, no problem. Kaushik? Kaushik, do you hear me? Okay.
Hello, sir.
Do you understand this problem? Yeah, this is
After 5 minutes, daddy class will be completed.
Yeah, now, do you understand this problem? This is an important model.
Yes, sir.
So I'm erasing this. So that's what the answer, what we have got is 9/2, option B. Next one. A line with direction cosines proportional to 2, 1, 2. A line with direction cosines proportional to 2, 1, 2 meets each of the lines x is equal to y plus a is equal to z, and x plus a is equal to 2y is equal to 2z. The coordinates of each of the points of intersection are given by. Coordinates of each of the point of intersection are given by. So first of all, understand the question, please. Direction cosines of the line is given to be 2, 1, 2. Required line dRs are given. dRs of required line. I should not say required line. The line dRs of a line are proportional to 2, 1. Let us write that. Now this is equation 1, let me say first line. And second line is given to be x is equal to y plus a is equal to z. This is second line. And third line is given to be x plus a is equal to y, 2y is equal to 2z. First of all, understand the question, please. Both of you. Please understand the question. What is saying? The first line is intersecting these two lines, and what he is asking is, he is asking for the point of intersection of these line 1 with 2 and 3. Let me show you that. This is first line, let me say, and this line is intersecting two more lines. This is one line, let me say, this is the second line. Now I'm naming them. This is first line. This is second line. This is third line. What he needs is the point of intersection of 1 and 2. Let me say P. Point of intersection of 1 and 3. Let me say Q. We need the coordinates of P and Q, please. We need the coordinates of P and Q. Okay? So, this is what you have to understand. Now, dRs of the required line is given to be 2, 1, 2. And this is one of the lines. This is one of the lines. Now, let me say these dRs are 2 and 2. We don't know the point of intersection for this. A point. So let us suppose, let line 1 passes through, let line 1 passes through x1, y1, z. Kaushik. Praneeth. Do you tell me now the parametric form or symmetric form of this line with 2, 1, 2 as dRs and the fixed point as x1, y1, z1? X minus
1
by 2 is equal to y minus y1 by 1 is equal to z minus z1 by
2.
Correct, no? Now you can create a point on it. What is it? You take it as some lambda, please. Take it as some lambda. x1 plus 2 lambda, comma, y1 plus lambda, comma, Z1 plus 2 lambda. This represents every point at any point on the first line. But we need particular point P and Q. We need particular point P and Q. So now I'm changing color for green because I'm talking about line 2. Line 2 drawn in green color. Line 2 now, line 2. So what is the point to be taken here? Let us suppose this is something like K, let me say. Then do you tell me what is the general point for this? Line 2, please. I'm talking about line 2. 2 implies XYZ is equal to, you tell me, K, comma, K minus A, comma, K. It is for line 2, please. Now line 3,
Okay, sir.
line 3, let us suppose this is something L, let me say. Then if it is L, do you tell me similarly what is the general point for 3?
L.
L minus A.
Correct.
L minus A.
L by 2.
Correct.
L by 2, sir.
That's right. Now, if these are intersecting, if these are intersecting, this 1 and 2 are intersecting. This is 1. This is 1, please. Now, for 1 and 2, you have to equate them. 1 and 2 equate them. That is 1 is equal to 2 here. That is first equation is equal to second equation. Then thereby, what is that you get? X1 plus 2 lambda is equal to K. One equation. And Y1 plus lambda is equal to K minus A. And third one, Z1 plus 2 lambda is equal to K. Now you have to solve them to get the value of the X1, Y1, Z1. That is, so we need the point of intersection for this one. Point of intersection for this one. Okay. So to get the point of intersection, you can check the options also. You can check the options also like this. Let me show you that. One moment. See, let me remove this for a moment. Okay. Now these are the lines given. Just check it out, please. Check it out. This is the first line. This is the second line. We wrote that. I took it as K. And I took it as L. We got 2 points here. P and Q. We have got 2 points here. Now, if you have these 2 points, then you can verify the options I said. Whether these points are satisfying this line and this line, you can check it out. So we got P and Q. I to name them as P and Q only. So we got P, Q as the points on the line. Now what we need is the point of intersection. So DRs of the given lines are 2, 1, 2, and DRs of PQ are DRs of PQ. How do we write? PQ means this is P, this is Q. If this is P, this is Q. How do you write the DRs? X2 minus X1, Y2 minus Y1, Z2 minus Z. X2 minus X1, Y2 minus Y1, and Z2 minus Z1. Just see this. So if you write that, these are the DRs of PQ. But that is very much similar to that line required line. So from that one, we get the lambda value and mu value, and thereby PQ values. Okay. So this is the method you can follow to find out the point of intersection. Let me show you that now. Let me show you just a moment. See, this is one thing you have to understand here. You tell me whether the yellow line here is same as PQ or not? Respond, please. I repeat, whether the yellow line is same as PQ or not. PQ is the yellow line and P is one point of intersection, Q is another point of intersection. Of course, these two are lying on the same line, you know. That means if I say PQ line and if I say the yellow line whose DRs are 2, 1, 2, both are same. Correct or not? I repeat.
Sir.
PQ is same as yellow line. Let me say this as P. Which one? 1 and 2 as P. Let me say 1 and 3 as Q. This is Q. Do you tell me DRs of PQ, please? Kaushik, DRs of PQ. DRs of PQ means x2 minus x1.
Yes, sir.
L minus A minus K. L by 2 minus K plus A. And it is L by 2 minus K.
Yes, sir.
And it is given that this is proportional to 2, 1, 2, please. Just check it out. Important model, please. Model is important. What I'm saying, I wrote DRs with the use of P and Q. These are the DRs. But the DRs are already given to be 2, 1, 2.
Yes,
DRs are already given to be 2, 1, 2, please. So these two must be same. That's what I'm saying.
Yes, sir.
These two must be same. Correct or not?
Yes, sir.
So in that case, what must happen? In that case, what must happen? They must be proportional, what I'm saying. They must be proportional, please. Okay. So let us make them proportional, please. How do we make it proportional? This is 2. Come on, tell me. L minus A minus K divided by 2 is equal to, second one, please. L by 2 minus K plus A divided by 1 is equal to L by 2 minus K divided by what? 2. Can you solve these two, please? For my sake.
Okay, sir.
This is L minus A minus K is equal to, multiply with 2. L minus 2K plus 2A. Then LL getting cancelled, you will get K is equal to A. K is equal to 3A. First one you got, K is equal to 3A. If you substitute here, you will get 1 point of intersection. This one you have to substitute, please. K is equal to 3A. Please substitute here.
Sir, sir, K equals to 3A.
Is equal to K 3A. 3A comma 2A comma 3A. This is 1 point of intersection. And Q, Pranit, you solve, we got already the value of K here.
Yes, sir.
You solve this first fraction and the last fraction, please. First and last fractions.
Okay.
I need the value of L. And of course, you can get the value of L from here also, I think. Just a substitute here. Instead of K, you write 3A. Instead of K, you write 3A in these two. And get the value of L, please, from this one. Kaushik, do you understand what I'm saying?
Yes, sir.
I need the value of L, please. Please make it fast.
Okay, sir. 3. CA minus by 2. So 100.
Yes, please.
Sir, I got L value as 3, sir.
L value,
As 3.
I think it must be in terms of A. Let me check one moment. If you substitute K3A here, this is, you'll be getting this as,
Yes, sir.
what is the value of L?
Sir?
L, please, L. L value. This 2 getting cancelled. L minus L by 2. L by 2. L by 2 is equal to, yeah, L is equal to 2A, I think. Because this KK getting cancelled, L minus L by 2. L by 2 is equal to A, L is equal to 2A. You'll get L is equal to 2A, please. You must get that.
I got the point, sir. Then we get the point A. A comma A, sir.
Okay. So you substitute this L value here. So what is that? You get then 2A minus A, 2A by 2A, triple A. So the answer is 3A, 2A, 3A, and A, please. Triple A. Pranit, just if you solve the first one and third one, you get it.
Okay, sir.
So what is that we did? We have taken the first line and we wrote the general form of it. And the second line and we wrote the general form. General form means which represents every point and any point on the line. We took PQ. Now the required line DRs are given to be 2, 1, 2. That means PQ. PQ are these 2 points. Then if you write the DRs of this in terms of PQ, that you got it in terms of L and K. L and K. But the DRs are already given to be 2, 1, 2. So if these are the DRs and these are the DRs of PQ, they must be same. That means they must be proportional. We applied proportionality here and then we got the values of L and K and substituted in P and Q to get the points of intersection. Just I have shown you this just to make you again understand the symmetric form. Okay. Now let us see the next problem. Foot of perpendicular. Foot of perpendicular. So reflection. I need to specially mention this foot of the perpendicular. If you drop a perpendicular from point A to on the line, it meets it in P, then P is said to be foot of the perpendicular. If you take the image of P in this line L, if it is Q, then Q is said to be image of P, or P is said to be image of Q in the line AB. AB is the line mirror. AB is the line mirror, and P and Q are the images to each other. Okay. Now the perpendicular distance also can be found out using the foot of the perpendicular. We will be doing the problems instead of seeing the theory here. Just see the question here, please. The coordinates of this model is important, please, because it is important in two-dimensional geometry and as well in three-dimensional geometry. If you see that the coordinates of the foot of the perpendicular drawn from the point A103 to the join of the points B471 and C353, or let me draw the diagram so that you'll have more clarity about this. Just a moment, please. See what is drawn from the point A103. I'm marking the points and we'll be working out the problem. A103 and the line is joining 2 points here, B and C. What is C353? What is B471? Now we need the foot of the perpendicular. Both of you, please listen to this. If you get any doubt, please ask me.
Okay, sir.
Now, what is that we did? We have drawn a perpendicular from A onto BC.
Yes, sir.
It meets BC in F, let me say, because symbolically I'm using it. F stands for foot. Foot of what? Foot of perpendicular. Now, what is that to be done here? We know that the angle between them, these two, is 90 degrees. When the angle between two lines is 90 degrees, you know, BC bar dot CF bar, AF bar, BC bar dot AF bar is equal to 0 because they are perpendicular to each other. Then if you want to write BC bar here, there's no problem. You can write DRs here, 3 minus 4, 5 minus 7, 3 minus 1, like that. You can straight away write DRs of BC, no problem. But if you want to write the DRs of AF, no, you must know F. F is not present here. But F is a point on the line BC. So we write the parametric form of BC. Understand this clearly, please. What I'm explaining is important here.
Okay,
it's
sir.
Important here. I'm creating every point at any point on the line BC. I'm creating every point on any point on the line BC. So for that, what I'm writing the symmetric form of the line BC. X minus 4, Kaushik,
Sir.
equal to Y minus 7 is equal to Z minus 1 divided by DRs of the line, 3 minus 4, or you can write 4 minus 3 also, no problem, whatever is convenient. Let us write 4 minus 3, 1, 7
2.
minus 5, 2,
Minus 2.
1 minus 3, minus 2. We wrote the equation of BC now. Now let us take it as some lambda, because I want to create every point at any point on the line. Thereby, I can take F now. I'm taking that particular point as F. F will be in terms of lambda. Do you tell me what is F now? Lambda plus 4. Cross multiply. Pranit. Lambda
Yes,
plus 4.
Lambda plus 4.
Comma.
Lambda plus 7.
2 lambda plus 7. And cross multiply. Minus
Okay.
2 lambda plus.
Plus.
Correct, no? So you have got the coordinates of F now by taking the symmetric form. By taking the symmetric form, this is F now. You know A, you know F, you know B, you know C. Now you can apply the dot product. You can apply the dot product, thereby you'll get the value of lambda. Thereby you'll get the value of lambda. So let me do that. Now, do you tell me BC bar, please? BC bar means OC minus OB.
Yes, sir.
Come on, tell me what is OC minus OB. It is already there written.
Yes, sir. Minus then we have times. Minus 1.
This one only. 1, 2, minus 2. Correct? No?
Yes, sir.
This one now I am applying. Come on, tell me that. Now I am applying 2, 1 within brackets plus 2 within brackets plus minus 2 within brackets. What is that? I mean, what I mean by that, just for your better understanding what I do, I'll write the formula condition for perpendicularity, please. Anyone? Both of you?
Sir, A1, A2 plus
Correct.
B1, B2 plus C1, C2.
Is equal to 0. Very good. This is what we are going to apply now. This is what we are going to apply now. So what is A1, A2, A1, B1, C1? Do you know what is A1, B1, C1, please? Nothing. DRs of BC.
Yes, sir.
Come on, tell me that now. DRs of BC are this one, 1, 2, minus 2. 1, 2, minus 2. I wrote that. Now that is I wrote A1, B1, C1. For more clarity, I'll show that. This is A1. This is B1. This is C1. Now tell me what is A to B to C2? Any one of you, please. What is A to B to C2? A to B to C means AF bar, no, OF minus OA. That is lambda plus 4 minus 1.
Lambda plus 4.
Lambda plus 3. Correct, no?
Yes, sir. 2 lambda plus 7.
Correct.
Sir, minus 2 lambda minus 2.
Very good. Must be equal to 0.
0, sir.
So this is 4 lambda plus 4 lambda, 8 lambda plus lambda, 9 lambda. Nine lambda, let us see the constant. 3 plus 14, 17, 17 plus 4, 21. Is equal to 0. Implies your lambda is equal to minus 7 by 3. Therefore, we need F here. F is nothing but the foot of the perpendicular. This F is got from this one now. So you have to substitute lambda in this one to get F. Come on, tell me. Now, what is that you get for F here? F is nothing but minus 7 by 3 plus 4, 12 minus 7, 5 by 3. Comma, 2 lambda plus 7 minus 14 plus 21. 7 by 3 minus 2 lambda plus 1 minus 2 lambda plus 1. It is nothing but minus 2 into minus 7, 14 by 3 plus 1. That is 14 by 3 plus 1 is 17 by 3. Just substitute the value of lambda in the equation in this foot of the perpendicular. That's what I did. Just check it out, please, whether it is correct or not, Kaushik.
Sir.
Now, this is the method you have to understand. So we got the foot of the perpendicular. We got foot of the perpendicular. Okay?
Sir.
So what is that we did? Let me review once. A perpendicular is dropped from A onto BC. B and C coordinates are given. A coordinates are given. If you drop a perpendicular from A onto BC, it is meeting BC in F. Now, because these two are perpendicular to each other, you know that BC bar dot AF bar is equal to 0. BC bar dot AF bar is equal to 0. Now what I'm doing, I'm writing the equation of BC because I know 2 points are it. That is x minus x1 by A. What is A? DRs, please. DRs of BC, please. What are the DRs of BC here? This is 4 minus 3, 1, 7 minus 5, 2, 1 minus 3, minus 2, or the DRs. And what is the point taken there? The point taken is 471. Just check it out, 471. And should we take only 471? Need not be. You can take even 353 also, no problem. You can write 353 also. You'll get the same answer. So I wrote the equation of BC, and thereby I created every point and any point on BC. Every point and any point on BC, I need F here. That is why I named it as F. F is nothing but lambda plus 4, 2 lambda plus 7, minus 2 lambda plus 1. Now this is F. I know A, I know F now in terms of lambda, and BC we know. Now because these two are perpendicular to each other, BC bar dot AF bar is equal to 0. And condition for perpendicularity, A1, A2 plus B1, B2 plus C1, C2 equal to 0. And A1, A2, A1, B1, C1, you know, it is 1, 2, minus 2. That's what I wrote. 1, 2, minus 2 I wrote. And A2, B2, C2 is got by OF bar minus OA bar. This is F. This is A. I wrote OF bar minus OA bar. This is lambda plus 4 minus 1, lambda plus 4 minus 1, lambda plus 3, 2 lambda plus 7 minus 0, 2 lambda plus 7, minus 2 lambda plus 1 minus 3, minus 2 lambda minus 2. We simplified this and we got the value of lambda minus 7 by 3. What we need is foot of the perpendicular. So we substituted lambda in this one, and thereby we have got the foot of the perpendicular as 5 by 3, 7 by 3, 17 by 3. I think it's clear.
Yes, sir.
Now, if you don't want to do the method, if you're not willing to do the method in this type of problems, you can straight away go for cross verification with the options. Pranit, how to go for the cross verification of options? Let us see that.
Okay, sir.
Let us see that. What is the answer we have got? Is it that? Yeah, option A, we have got it. Now, see, for example, you don't want to go for the method, then how to proceed? You can see clearly from the diagram what I have drawn. I'm drawing it again for your purpose. See, this is the foot of perpendicular drawn from A onto BC. Drawn from A onto BC. This is A piece. This is B piece. This is C. Now what we do, we know that these two are mutually perpendicular, and hence your F is lying in the answer. Your F is lying in the answer. Your let me do it like this. Your F is lying in the answer, and your C is this, your A is this, and your B is this. Correct now?
Yes, sir.
Now, what I have to verify, BC bar dot AF bar must be 0. So we will see which F is satisfying. F is in the options. So let us check it out. Let us check it out. BC bar is easy for you. This is 4 minus 3, 1. This one, 4 minus 3, 1. 7 minus 5, 2. And 1 minus 3, minus 2. It is there. Now, let me write AF bar. This is A. A is what? 103. 103, 5 by 3. 5 by 3, 7 by 3, 17 by 3. 1 minus 5 by 3, please. Or 5 by 3 minus 1. Whatever, no problem. 5 by 3 minus 1. 2 by 3. Plus 2. And 7 by 3 minus 0, 7 by 3. And it is 17 by 3 minus 3, 17 minus 9, 8 by 3. Check it out, please, whether it is becoming 0 or not. 2 plus 14, 16 minus 16, 0. Just check it out, please. Check it out, you have got 0. Whatever the option is giving you 0, that
Yes, sir.
That will be the answer. And it is not possible in three-dimensional geometry to get double answer. To get double answer, it is not adjustable. It is not adjustable. That is the reason why you will have only one correct option like this. So what is the cross verification method? I repeat, A given, B given, C given, F is in the answer. F is we find out that F is in the answer, but we know that these two are mutually perpendicular to each other, and hence BC bar at AF bar is equal to 0. This is to be verified, and F is in the answer. A, B, C are given. So what is that I did? I wrote the DRs of BC. It is 4 minus 3, 7 minus 5, 1 minus 3. So 1, 2 minus 2 are DRs of BC, and AF bar means A I know 1, 0, 3. And F is 5 by 3, 17 by 3, 7 by 3, 17 by 3, x2 minus x1, y2 minus y1, z2 minus z1. I substituted here a1, a2 plus b1, b2 plus c1 should I got it to be 0, and hence this is the answer. For rest of them, you don't get it. Of course, here it is in the first option, and if first option is not satisfied, you have to go for the second option also. So I explained to you both the method and the cross verification. I hope you understand that. Kaushik and Praneeth, is it clear?
Yes, sir.
Now, here also, first of all, what I explain you, I'll explain you the cross verification first, and then we'll go for the method, because we did the
Okay.
method.
Yes, sir.
Now, this is the line given, the image of the point 163 in the line x by 1, y minus 1 by 2, z minus 2 by 3. If you draw the line, you know, this is the line, let me say. This is the line. And the image of the point. So this is the point, let me say. Let me say this as P. Okay, now you need the image of it. You need the image of it, please. P image in the line, let me say this as P dash. Now, Kaushik.
Sir.
Now this line is given. No, what are the DRs of this line? It is clear. It is easy. Still easy than that. 1, 2, 3 are the DRs of this line. Correct?
Sir. 1, 2, 3.
1, 2, 3. And what is a point given? 1, 6, 3.
Yes, sir.
Let us check for again perpendicularity condition. What is a perpendicularity condition, please? A1, A2, as you said in the previous case, A1, A2 plus B1, B2 plus C1, C2 equal to 0. For the first one, what is the first option here? 107. I'm talking about first option, please. First option. First option is 107. Come on, tell me now. Verify A1, A2 plus B1, B2 plus C1, C2. So what is A1, A2? A1, B1, C1. 1,
1,
2, 3. Correct now?
yes, sir.
Now A2, B2, C2, that is 1 minus 1, 0.
2, minus 6.
That's good. Minus 6.
5, 4, sir. Yeah.
4. Is it 0 or not?
Yes, sir.
It is 0. So the answer is this only. That's it. You don't have to go further. Of course, it is given in the first option only. That is why you are getting in the first option itself.
Yes, sir.
You can even check BC also. It is easy to check BC also. If it is minus 107, what happens? Minus 1, this becomes minus 2 then. This becomes minus 2. This remains the same, and it will not be 0 for the second option. Then for the third option also, it is minus 7. It is not happening. So cross verification, you have to go like this. If you want to go for the method, it is also to be proceeded from foot only. You have to, in the previous case, we did the method to find out the foot of the perpendicular. Find out foot, and this foot is nothing but the midpoint of P and P dash. Foot is nothing but midpoint of point and its image, isn't it? F is nothing but P plus P dash by 2. if you find out f, p dash is nothing but twice f minus p, cross multiply, twice f minus p. So whatever the image is to be find out, image is to be proceeded through foot only. Again, image is to be proceeded through foot of the perpendicular only. This is what the method and the cross verification. Okay. So he did the same, just see that he did the method there, and we have learned both. Okay, that's it. This part is over, and the last part of it is finding the perpendicular from the origin. Image of the point again, we can do that. The most important one is the skew lines. Skew lines is the most important concept in three-dimensional geometry and in vectors and 3D. So we will be doing this in the next session. Skew lines, shortest distance between the skew lines. We did it, I think, already in vector algebra. We did it, but
Yes, sir.
we will see just the extension of that vector algebra, or extension, or even how do we convert that vector formula to 3D formula only. We will be seeing that. So shortest distance between the skew lines, we will see that, and then this is the most important topic.
Okay, sir.
Concept, even we can say, and the last one is the plane. Plane will be the last part of three-dimensional geometry. Okay, and do you remember any? Okay, we will see the skew lines and after that planes in the next session.
Okay.